Today we're going to be talking about the algebra of functions. We're going to see this, again, and transformation of functions. But let's get started. So for the algebra of functions, let me just kind of start with an example here. Let's say you've got a job. So this is the job number, and you've got Sue doing her part of the job, and you've got Jim doing his part of the job, and you've got a total. So for the first job that they're doing, let's say this is the hours worked. Okay, so Sue, let's say she does 3, Jim does 4, the total is obviously 7. For job number 2, Sue works again for 3, Jim for 5, which gives you a total of 8. Okay, and you could go on for that. You could go on. And so, I'm just for space-wise, I'm going to do this. All right, so we could then say then that f of 1, which is job number 1, equals 3. And we could say g of 1 equals 4. So it's obvious that I'm referring to Sue as f and I'm referring to Jim as g. And so for Sue, f of job number 1 would be 3. So the x coordinate's 1, the y coordinate's 3. Jim would be x coordinate's 1, y coordinates 4. So the job number is like the x, and these are like the y's. So f of 2 would be 3, and g of 2, what would Jim's amount of work be, was 5. And if I added another one, say job number 3, and they did 4 and then 3, total of 7. Now f of 3 is equal to 4, and g of 3 is equal to 3. So their total hours would be 7. So we'd say t of 1 equals 7. Their total hours on the next one would be 8. So t of 2 equals 8, and their total hours on the third job would be 7. So how do we get the 7, 8, and the 7? Well, you add the hours together. So you're basically adding the f of 1 answer and the g of 1 answer. So the algebra of functions is kind of talking about adding those things together. So we say f plus g of 1 is equal to f of 1 plus g of 1. In our examples, that was f of 1 was 3 plus g of 1, which was 4, and that was 3 plus 4, and they're both equal to 7. So we can add some functions together. So there's some formulas for that. We can add functions, we can subtract, multiply, and divide. So one of the formulas is f plus g of x equals f of x plus g of x. The second one is f minus g of x equals f of x minus g of x. Third one, f times g of x equals f of x times g of x. And the fourth one is f divided by g of x is equal to f of x divided by g of x. And I guess a kind of a fifth one we could say is a f of x means a times f of x. So if you have a number out in front of any of those, you just multiply it times the f of x. So let's take a look at an example. This first example is a little bit tricky, so I'm going to put a note at the bottom. So go to the bottom with me, and I want to just write a little note down here that says the domain, because we're asked to find the domain on these, the domain of, and it could be f plus g, it could be f minus g, or it could be f times g, is the set of elements common to the domain of f and of g. Or the domain of f plus g, f minus g, f times g, any one of those, is the intersection of the domain of f and g. Now, the domain of f divided by g or g divided by f is the set of elements in common except for division by 0. Okay, so we got to keep that in mind. The domain is the set of elements common to the domain of f and of g. All right, so let's go to the top here and start asking us for the domain. On the first one, it would be just the x coordinates, remember? So 0, 1, 2, 3, 4, 5, and 6. The domain of g is 1, 2, 3, 4, 5, 6, 7. Okay, f plus g, what's the domain of f plus g? Well, remember, the domain of f plus g is the set of elements common to the domain of f and of g. So what are the common elements here? Well, we've got 1, 2, 3, 4, 5, and 6. Those are the ones they have in common. Therefore, the domain of f plus g would be 1, 2, 3, 4, 5, 6, which is also true for g minus f, f times g, but not g divided by f. The problem with g divided by f is that when we get to the domain for 6, they have that common domain of 6. If you're going to divide g by f, that would be taking 18 divided by 0. You'd have a 0 in the bottom of a fraction. So if it was f divided by g, we'd be fine. But g divided by f, we can only look at 1, 2, 3, 4, and 5. Because there cannot be any division by 0. Next, it's asking for the ordered pairs and set notation of f plus g. Well, what that means is you keep the common domain. Now, if you look up at the job, the example up above, if you think about it, we added the y coordinates. 3 plus 4 is 7. We kept the x coordinates 1, 2, and 3 the same. So that's what we're going to do here, is look at what they have in common. And if they didn't, so back to the job question a second. If they didn't have anything in common, so let's say Sue works on job number 4, but Jim does not, then you wouldn't count job number 4 in the domain. So that's kind of what we're going to do down here. We are going to add the y coordinates of the x coordinates in common. Okay, so 1 comma 6 or 5 plus 3. 2 comma 4 plus 6. I'm adding the 4 and the 6, okay, because that's what the y coordinates of the x coordinates in common. 3 comma 3 plus 9. 4 comma 2 plus 12. 5 comma 1 plus 15. And 6 comma 0 plus 18. So putting that all together, we get 1 comma 8, 2 comma 10, 3 comma 12, 4 comma 14, 5 comma 16, and 6 comma 18. So that's the answer to that piece of it. We're going to do the same exact thing for g minus f. This time, though, we're going to subtract y coordinates of the x coordinates in common. So it's going to be g minus f. So I'm going to start with the common 1 and do 3 minus 5. Not 5 minus 3 because it's g minus f. 2 comma 6 minus 4. 3 comma 9 minus 3. 4 comma 12 minus 2. 5 comma 15 minus 1. 6 comma 18 minus 0. So that result is 1 comma negative 2, 2 comma 2, 3 comma 6, 4 comma 10, 5 comma 14, and 6 comma 18. So those are the coordinates for g minus f. All right, so then obviously we're going to do the same thing for e. We're going to now multiply the y coordinates of the common x's. So multiply y coords common x's. Okay, so 1 comma, we're going to take 5 times 3. 2 comma 4 times 6. Oh, I'm just going to write that this time. We can handle that. We don't need to write that out. That's 24. 3 comma 3 times 9. 4 comma 2 times 12, so 4 comma 24. 5 comma 1 times 15, or 15, and 6 comma 0 times 18, or 0. So now you can see why with the division we can't include 6, hopefully, because we're going to end up getting a division by 0 here. We're going to end up getting a 0 in the bottom. So we can't include 6 in our domain. So now we're going to divide the y coordinates of the common x's. So I'm going to take 1 comma, and I'm doing g, so 1 comma 3 divided by 5. And I'm doing 2 comma 6 divided by 4, which is 3/2. And 3 comma 9 divided by 3. And 4 comma 12 divided by 2, which is 6. And 5 comma 15 divided by 1, which is 15. And you see, if I went 6 comma 18 divided by 0, no, can't have that. So this is the list of ordered pairs. Okay, next page. So now we're going to look at functions, not ordered pairs, actual functions. I mean, other ones were functions too, but now we're looking at them not just ordered pairs. Given the domain of f of x and g of x are all reals, and the domain of h of x is greater than or equal to 0, f of x, g of x, h of x. Write each function value in terms of x. So g plus f of x, we know that formula is equal to g of x plus f of x. So let's do that. G of x is 2x squared plus f of x, which is 6 minus 3x, and just put it in standard form. 2x squared minus 3x plus 6. And you need to consider the domain of both of them and the domain of the ending one. In the domain of both of them, they were all reals, so the domain of the ending one will also be all reals. You don't have a fraction or a radical, so you don't have to worry about the domain. G minus f of x is g of x minus f of x. So let's take and do 2x squared minus 6 minus 3x. Remember, you have to distribute that negative, so that's 2x squared plus 3x minus 6 when we distribute that. And circle my final answer there. The domain on that is, again, all reals. There is not one value I could not enter in for x. I can enter any value in for x I want. G times h of x is the same as g of x times h of x. And that is going to be 2x squared times radical x. Nothing we can do with that, so it's just 2x squared radical x. That's the answer for that part. But the domain is x has to be greater than or equal to 0, because you cannot have a negative underneath that radical. G divided by f of x is equal to g of x divided by f of x. So take g of x, which is 2x squared, and divide it by 6 minus 3x. So nothing can be simplified there, so that's that answer. And in this case, when we're going to the domain, you cannot have 0 in the bottom of the fraction, so we need to look at what makes that denominator 0. So set it equal to 0. Negative 3x equals negative 6. X equals 2. So it's going to be all reals except 2, and we can say that by just writing x not equal to 2. And you could also write out all reals except 2. the last, second to last one, g plus 2 times f of x is equal to g of x plus 2 times f of x. So that one's going to look like 2x squared plus 2 times f of x, which is 6 minus 3x. So when we clean that all up, we get 2x squared, 2 times negative 3x minus 6x plus 12. And that's again a parabola, so we're talking all reals for the domain. And then the last one is equal to negative g of x times f of x. So I'm just going to negate g of x, so negative 2x squared times 6 minus 3x, which is, in standard form, positive 6x cubed minus 12x squared. And there's, again, no limit to what I can enter in for x, so that has a domain of all reals. Okay, the next page kind of talks about what happens if we, take and transform these y coordinates. So it's kind of like the algebra of fractions. It just looks a little bit different. So the first example is f of x equals x squared minus 3. And we're going to find f of 0 for each function. So it says to graph it, so I'm going to start with table of values. So I get, in my calculator, I think I'll go with negative 2, negative 1, 0, 1, 2. And negative 2 is 1, negative 1 is negative 2, 0 is negative 3, 1 is negative 2, and 2 is 1. And I was looking for that rainbow effect, which gave me my minimum. Okay, so 0, negative 3, negative 1, negative 2, 1, negative 2, 2, 1, and negative 2, 1 gives me my graph. Okay, so find f of 0 means when x is equal to 0, what's y equal to? Well, you can see that in the table of values. It's equal to negative 3. So that's the answer to A. Find x when f of x equals 0. Now remember up here that this is, that f of x is really the same as y. So what B is asking is it's saying, what is x when we know that y is 0? That's what we're looking for. So what is x when y is 0? So if I have y equals 0, what's the x? Well, you could solve that algebraically, and you could say 0 equals x squared minus 3, and then you'd have 3 equals x squared, and then x is equal to the square root of 3 plus or minus. So when y is 0, x can be negative radical 3 or positive radical 3. So the answer for B is plus and minus radical 3. So if we kind of look over here, the square root of 3 is like 1.7 and negative 1.7. That kind of looks like it's going to hit right there at the x-axis. There's x and y at 0. For C, sketch the graph of y equals f of x minus 2. So what that means is f of x means y again. So what we're going to do is subtract 2 from all the y coordinates. kind of what we did in the previous page. So I'm going to make another column here and set up another y, but it's going to be y minus 2. So I'm taking my original values of y there and subtracting 2 from them. And I get 1 minus 2 is negative 1. Negative 2 minus 2 is negative 4. Negative 3 minus 2 is negative 5. Negative 2 minus 2 is negative 4 again, and 1 minus 2, we're back to that rainbow. If I wanted to do those, I could as well. So now, to graph that, I'm going to use the original x's always. These were the domain that they had in common. Okay, so we're going to go with negative 2 and negative 1. So negative 2, negative 1, negative 1, negative 4. You should notice something. I think what I see happening is that all the coordinates are just going down 2. Down 2. Down 2. So I'm getting a parabola that's going like that. So all it did was took the original parabola and moved it down 2. So that's what's going on with C, is it moves down 2. Now for D, now what we want to do is, let's see, let's get a different color here. Let's get a, let's see if I can get an orange. So there we go. All right, so sketch, no, you know what, I don't want an orange. I want a darker color. I'm going to go with black. Okay, so for this one, we're going to take 3 times y. And it's going to be the original y. Okay, so it's going to be 3 times this original y. So it's going to be 3 times y. So when I take 3 times that y, I get 3. 3 times negative 2 is negative 6. 3 times negative 3 is negative 9. 3 times negative 2 again, negative 6. 3 times 1, 0, 0, if I want to plot those. So now, when I plot that, I'm going to use the original x again. So negative 2, 3. Negative 1, negative 6. 0, negative 9. 1, negative 6. And 2, 3. So what's going on here, I'm just going to do dotted because it's kind of hard because it's kind of skinnier. So what's going on with that parabola is it should be looking like it's getting steeper, skinnier. And then sketch the graph of y equals negative f of x. Let's see what this one looks like. Let me go see if I can grab another color. Let's see how yellow works out. Oh, okay. All right, so what this one's going to do is we're going to negate or take the opposite of the y's. Okay, so if I kind of add over here negative y, I'm going to just negate them all, the original. So again, I'm taking and looking at that y and negating it. So negative 1 positive 2, positive 3, positive 2, negative 1. You can't negate 0. So that's what I'm going to try to graph now with the original x. So negative 2, negative 1. I already shared that point with somebody else. Negative 1, 2, 0, 3. You can see it's going to now flip over that x-axis. Okay, so I'm going to label this was E. The black one was D. The green one was C. Oh, I don't have a green one. The red one was subtract. I ended up doing it in red. That's confusing to me. Okay, so that was that one. All right, so the red one was C, and then the blue one was the original equation. Okay, so what happened there was this one reflects over the x-axis. So I'm going to stop the lesson here because it's going a little long, and that's basically what you're going to do with your diagrams. If you look at your diagrams, I could have moved this down to, I could have taken all the y coordinates, multiplied them times 3, or done the reflection over the x-axis and just negating, using the same x coordinates every time. Okay, good night. Thank you.